Hello friends! Even with vacation season going on, I still got some exciting news for you. So let's see, what is new in power semiconductors industry? The United States has fallen behind China and Europe in the production and adoption of electric vehicles, especially from 2017 to 2020, according to a study by the International Council on Clean Transportation. One important piece of that puzzle that the United States does have supremacy in, however, is the production of semiconductors, which are used in everything from smartphones to computers to electric vehicles. Now it might be strengthening that hold. SK Siltron CSS, a unit of South Korean semiconductor wafer manufacturer SK Siltron, announced plans to invest $300 million and create up to 150 high-paying skilled jobs in Bay County, Michigan, which is a couple of hours north of Detroit, the country's first automaking haven. The wafer manufacturer already has a presence in nearby Auburn, so the new factory will more than double its employee base. Over the next 3 years, SK Siltron says its investment will provide manufacturing and R&D capabilities of advanced materials for electric vehicles. 25 years ago, i-Micronews started collaborating with the University of Catania on silicon carbide, which is transforming electric vehicles today. To celebrate the 25th anniversary of silicon carbide, ST decided to explore its role in the industry today, how they got there, and where they're going. According to a study by Exavat, 70% of passenger battery electric vehicles will use silicon carbide MOSFETs by 2030. The technology is also transforming other markets, such as photovoltaic converters, energy storage, power supplies for servers, charging stations, and more. It is thus critical to understand silicon carbide's journey during these last 25 years to help today's and tomorrow's engineers. Silicon carbide's story is fascinating, but also fierce, because it shows that to be the best, it is also essential to be the first. Silicon carbide's properties were well established in the early 20th century, with the first SiC LED dating back to 1907. Physicists knew silicon carbide had a wider band gap compared to silicon. At room temperature, it meant silicon carbide devices had a critical electric field that could be 5 to 10 times superior. As a result, the new technology could vastly improve conversion efficiency while tolerating higher voltages and harsher conditions. Read the full silicon carbide story of STMicroelectronics in their blog. In competition with silicon carbide and gallium nitride have made remarkable progress in the power electronics business over the last decade. Following Tesla's adoption of silicon carbide in its main inverter, automotive has become the killer application for silicon carbide. Since then, silicon carbide has entered the priority list of almost all car makers. While BYD has also chosen silicon carbide in its premium models in 2020, Audi, Volkswagen, and Honda are expected to adopt silicon carbide in their next generation models. Despite the global slowdown in first half of 2020 due to the COVID-19 outbreak, design wins for silicon carbide solutions have recently multiplied, with a bright market outlook for 2019-2026 period. Facing a fast-evolving market and a pandemic crisis in 2020, Yellow Development is publishing a monitor containing world-class research, data, and insight pertaining to compound semiconductor markets in quarterly installments. This monitor analyzes the compound semiconductor market's evolution in terms of revenue, shipments, and price, as well as market focus per market segment, compound semiconductor design, wafer, and epi-wafer market dynamics. Understanding how heat flows out of a power module is crucial for power design. This Semikron webinar explains how thermal resistance is derived by a power module manufacturer, some techniques used for measurement, and how the values given in a datasheet can vary between module types and manufacturers. Additionally, the concept of thermal coupling and how operating modes influence thermal resistance will be discussed. This webinar is a natural extension of the previous Semikron webinar, How to Read an IGBT Datasheet. Join Semikron online on July 27. That's it for today. Thanks everyone for watching. As usual, see you next week. Meanwhile, go to Marketing Cycle website for more information or join me in social media. Keep in touch.